Welcome back, dear cosmic explorers. Tonight's journey takes us to a place where something ancient sleeps between the galaxies, waiting for the stars to align just so. Don't forget to like and subscribe if you're enjoying this ride with us. Drop a comment letting us know where you are listening from tonight and what time you usually fall asleep. As we settle in, let's share some warmth across the cosmos. Your stories light up our nights too. So snuggle into your favorite spot and let's begin this tranquil journey together. In the vastness of intergalactic space, where one might expect nothing but emptiness, dark matter accumulates in colossal structures, shaping the universe's grand architecture from a near-total vacuum. At -270 degrees Celsius, this ancient entity is colder than even the most frigid reaches of our solar system, yet it exerts a gravitational influence that binds cosmic structures together. Across 5 million light-years away, and spanning a diameter rivaling the Milky Way at about 500,000 light-years, this dark matter web drifts at a speed of 300 kilometers per second relative to the cosmic microwave background radiation. This movement is imperceptible on human timescales, yet it has been ongoing for nearly as long as time itself, 13.8 billion years. In contrast, our brief human lives are mere blips in this cosmic expanse. Remarkably, this intergalactic void hosts a temperature closer to absolute zero than anywhere else in the known universe, yet its influence permeates vast expanses. If you were to stand amidst these structures, hypothetically speaking, you would feel no cold. Heat requires matter, and there is little here. The radio waves emitted at 1420 MHz mimic hydrogen spectral lines, a relic of the early universe's formation processes. These waves have traveled millions of years before reaching us, carrying information about the universe's earliest moments. Imagine a human lifetime stretching across this scale. Our brief moments would be infinitesimal compared to the age of this entity. The iron in your blood was forged in ancient stars that died before the universe had even reached its current state of complexity. As you listen, consider that these processes have been at work long before life on Earth existed, and they will continue for billions more years after our sun has burned out. This intergalactic void is not just a place of coldness, but also one of profound isolation, where the nearest stars are millions of light-years away. While sound cannot propagate here due to the lack of matter, electromagnetic radiation travels freely. This environment is a stark reminder of how differently light behaves compared to what we experience on Earth. The radio waves from this entity have traveled through the void for millions of years before reaching us, each photon telling a story of cosmic evolution that predates our understanding of time itself. In contrast, the light from distant galaxies takes millions of years to reach us, yet it is still a fraction of the age of this ancient structure. The gravitational pull of this dark matter web is equivalent to 1.4 solar masses, suggesting a supermassive black hole at its core or something far more enigmatic. This accumulation is not static. It shapes galaxies into their present forms while influencing future cosmic landscapes. The density of matter in these voids is so low that stars and planets cannot form, Yet the structures they create are among the most massive in the universe. These intergalactic voids play a crucial role in the formation of galaxy clusters, acting as gravitational wells that draw galaxies together. In this environment, the vacuum allows electromagnetic radiation to travel freely between galaxies, undisturbed by any medium that might absorb or scatter it. This process underscores how deeply interconnected our universe is, despite the vast distances separating its components. The structures formed by dark matter are not just static entities, but dynamic participants in an ongoing cosmic dance, constantly reshaping and redefining the universe's architecture. Over billions of years, these voids will continue to influence the distribution of galaxies, guiding their movements and interactions across the cosmos. The ancient entity drifting between galaxies is older than any star within its vicinity. It has been present since the cosmos first began to take shape after the Big Bang, a staggering 13.8 billion years ago. This object spans 500,000 light-years across, larger than our own Milky Way galaxy, and colder than anything we can find on Earth at -270 degrees Celsius. In this void, where matter is sparse and gravity exerts a faint influence, it remains an enduring relic from the universe's infancy. Imagine standing beside this ancient entity in the vacuum of space. The temperature here would freeze every drop of moisture inside you in mere moments. Yet, paradoxically, at such extreme coldness, molecules barely move, preserving this relic like an artifact sealed in time. Its age is nearly equivalent to that of the universe itself, making it one of the oldest structures we have ever observed. This vast expanse holds a gravitational pull stronger than 14 solar masses, hinting at its possible identity as a supermassive black hole. The entity emits radio waves at precisely 1420 MHz, a frequency identical to the spectral lines produced by hydrogen atoms. Relative to the cosmic microwave background radiation, it drifts at a speed of 300 kilometers per second, remarkably slow compared to the velocities of stars and galaxies. For context, consider that even in our own galaxy, light from one end reaches the other in just 10,000 years. Here, due to the sparse density of matter, electromagnetic waves traverse for millions of years before reaching us. This entity is located approximately 5 million light-years away from our Milky Way galaxy, a distance so immense that any signal sent now would take more than 10 times the span of human history to reach it. In this intergalactic void, the entity's coldness approaches absolute zero, where quantum effects become dominant and particles barely exist above their lowest energy state. Within this extreme environment, we detect faint radio emissions, a testament to its enduring presence since cosmic dawn. The dark matter that composes most of the entity, around 85% of the total mass in the cosmos, remains mysterious but essential for structure formation throughout galaxies. In this intergalactic void, the entity is a solitary beacon amid vast tracts of empty space. Its coldness approaches absolute zero, where quantum effects become dominant and particles barely exist above their lowest energy state. Within this extreme environment, we detect faint radio emissions, revealing unexpected activity, tiny fluctuations in temperature that suggest ongoing interactions with nearby clouds of hydrogen gas, despite the otherwise stable conditions. While our understanding of this entity is limited by the tools available, it provides profound insights into the early universe's conditions. Over billions of years, this ancient relic has remained largely unchanged, a stark contrast to the dynamic evolution of stars and planets within galaxies. In a billion years, it will still be here, drifting through space with minimal perturbation from its remote location. The entity's longevity challenges our perception of time on human scales. A single rotation around the Milky Way takes about 250 million years for stars like ours. Yet this ancient structure has completed countless such rotations since long before life emerged on Earth. Consider that the universe is roughly 13.8 billion years old. This entity, born in the earliest moments of cosmic history, has seen all that exists today form around it. It predates not just our galaxy, but also the formation of galaxies themselves. The time it has endured surpasses any single human lifespan by a factor of billions. Yet its presence remains as constant and unchanging as the laws of physics themselves, an eternal witness to the birth of stars and the death of universes. In intergalactic space, where galaxies drift apart like islands on an endless sea, there exists a vast and ancient entity. At -270 degrees Celsius, this structure is colder than even the coldest regions within our own galaxy. Its surface temperature hovers near absolute zero, yet it remains active, emitting faint radio waves with a frequency of 1420 MHz, similar to hydrogen spectral lines. This entity spans approximately 500,000 light-years in diameter, rivaling the size of the Milky Way itself. The vastness of its scale is not easily grasped. Consider that if Earth were a grain of sand, this object would be an expanse stretching from here to beyond the Moon. Gravitational waves ripple through spacetime like subtle ripples across a cosmic lake, subtly altering the structure of this ancient entity. These ripples are generated by cataclysmic events in distant galaxies, collisions of black holes or neutron stars, phenomena that warp the fabric of reality itself. Each wave carries information about its source, traveling at the speed of light for millions of years before reaching our part of the universe. As these waves pass through the entity, they cause minute deformations in space-time, altering the delicate balance of gravitational forces around it. Yet, despite this disturbance, the entity remains stable, a testament to its immense mass and dark matter composition. The entity's drift at 300 kilometers per second relative to the cosmic microwave background radiation reveals that it is moving through an invisible river of dark matter and energy, shaped by the gravitational fields of surrounding galaxies. This velocity corresponds to a shift in the temperature of the cosmic microwave background by approximately 1 millikelvin, indicating its motion through space-time's subtle curvature. Over billions of years, this drift would have carried it across vast stretches of intergalactic space, its path influenced by the gravitational pull of distant galaxies. The entity's movement is not just a passive response to these forces, but an active participant in shaping the cosmic landscape around it, subtly altering the distribution of dark matter and influencing the formation of galactic clusters. At the heart of this entity lies a supermassive black hole, estimated at 1.4 solar masses. While this may seem small compared to some known black holes, Sagittarius A, for instance, has nearly 4 million solar masses. The gravitational influence it exerts is immense. The black hole's event horizon acts as the boundary of no return, where matter and radiation are drawn in with increasing intensity closer to its center. Any star or planet wandering too close would be torn apart by tidal forces, their remnants swirling into an accretion disk around this cosmic sinkhole. Yet, paradoxically, despite its powerful gravitational pull, this black hole remains isolated in the vast emptiness between galaxies, a lonely sentinel in a void. However, recent observations suggest that this isolation is not complete. There may be faint traces of other celestial bodies orbiting at extreme distances from the black hole, hinting at a more complex ecosystem than previously thought. The radio waves emitted by the entity provide astronomers with crucial information about its composition and history. These signals are part of the 21-centimeter line spectrum, a frequency associated with atomic hydrogen, and one of the most useful tools for mapping large-scale structures in the universe. By studying these emissions, scientists can infer not only the presence of dark matter, but also the entity's age and formation process. The radio waves have been traveling through space since before our sun was born, carrying messages from an epoch when the first stars ignited and galaxies began to form. This ancient light tells a story of cosmic evolution, illuminating how structures like this entity came into being in the early universe. As we observe this intergalactic phenomenon, it is worth reflecting on its role as both witness and participant in the grand narrative of the cosmos. The entity's existence bridges epochs, existing since before the Milky Way took shape. It has seen the birth of stars and galaxies, their life cycles unfolding like a cosmic ballet around it. In 1 billion years, it will continue to drift through space, its radio waves carrying messages into the future for any distant astronomers who might one day listen. For now, it remains in a state of serene suspension between galaxies, an ancient sleeper whose dreams are written in the language of gravitational waves and dark matter, waiting for the next chapter in the universe's story. In intergalactic voids, far beyond the reach of our nearest galaxies, temperatures plummet to unimaginable lows. At -270 degrees Celsius, these regions approach absolute zero, a state where all molecular motion nearly ceases. Yet within this frigid expanse, there are fluctuations, pockets of space that can be relatively warmer by mere fractions of a degree. These variations, though minuscule, are crucial for understanding the complex interplay between dark matter and energy in our universe. This paradoxical warmth arises from cosmic microwave background radiation, an echo from the Big Bang, which permeates every corner of the cosmos. Even here, where there is ostensibly nothing, this ancient light provides a subtle but significant influence on the temperature. Imagine standing at -270 degrees Celsius amidst intergalactic space. The temperature difference between these cold regions and Earth's coldest places, Antarctica's record low, is vast indeed. While our planet's chilliest spots hover around degrees Celsius, these voids are nearly 3 times as cold, a staggering disparity that defies the notion of extreme weather on Earth. This profound contrast highlights how our experiences with temperature are confined to a narrow band compared to what exists across cosmic scales. Despite this vast difference, these fluctuations in intergalactic temperatures are essential for astrophysicists studying dark matter distribution and its gravitational effects. They serve as subtle signposts guiding us through the unseen architecture of the universe. Within these cold voids, electromagnetic radiation travels unimpeded, free from interference that would occur within denser regions like galaxies or nebulae. The radio waves emitted by this ancient entity at 1420 MHz offer a unique glimpse into its nature and origins. These signals are akin to those produced by hydrogen atoms, suggesting the presence of hydrogen in gaseous form even amidst such sparse environments. This observation underscores how elements fundamental to life, including the hydrogen that composes water, exist throughout the universe, connecting Earth's chemistry with the broader cosmos. The precision with which these frequencies can be detected also reveals the technological sophistication required to probe deep into space, a testament to humanity's relentless pursuit of understanding. This ancient entity drifts at 300 kilometers per second relative to the cosmic microwave background radiation. This speed, while significant by galactic standards, is nearly imperceptible against the backdrop of intergalactic distances. Over millions of years, this movement subtly alters its position within the vastness of space, a slow dance that unfolds over epochs longer than human comprehension can easily grasp. The entity's velocity provides insights into the larger-scale structure of the universe, where even seemingly isolated objects like this one are influenced by cosmic expansion and gravitational pulls from distant galaxies. This motion also indicates that nothing in the universe stands completely still, not even ancient entities in intergalactic voids. Despite the near-total lack of matter in these regions, they are far from featureless. The entity's gravitational pull, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole or an equally enigmatic structure composed primarily of dark matter. This mass exerts a subtle but significant influence on surrounding space-time, warping it in ways that can be detected through precise measurements of distant light and radio emissions. The gravitational effects span far beyond the entity's immediate vicinity, influencing the paths of photons and particles for millions of light-years around. This demonstrates how even in environments where matter is scarce, invisible forces still shape the universe on immense scales. However, recent observations suggest that this entity may also emit unexpected bursts of X-rays, indicating possible interactions with dark matter particles or other unknown phenomena. As we observe this ancient entity, it is worth noting that its temperature is not entirely uniform. Small regions within these voids can exhibit temperatures slightly above -270 degrees Celsius due to localized cosmic events or nearby galaxy interactions. These slight deviations hint at a dynamic cosmos, where even the coldest reaches are subject to change over time scales incomprehensibly vast. The entity's composition, primarily dark matter, remains elusive to direct observation, but profoundly influences how we perceive the universe. Its presence challenges our understanding of matter and energy, prompting further exploration into the nature of dark matter and its role in shaping cosmic structures throughout the history of the universe. In the vast expanse of intergalactic space, far from any galactic hub, a human body would experience an environment nearly devoid of gravity and extraordinarily cold, conditions that challenge our everyday understanding of survival. Weightlessness dominates this experience, with every motion feeling exaggerated and almost surreal. In such an environment, simple actions like turning over or extending an arm require minimal effort, as there is no gravitational force pulling down on the body. This sensation contrasts sharply with the constant pull we feel on Earth, which shapes our daily movements and physical sensations in profound ways. The absence of gravity creates a floating limbo where time itself seems to stretch and slow. The extreme cold approaches absolute zero, a temperature where atomic motion nearly ceases. Skin rapidly loses heat to the surrounding void, cooling quickly despite the lack of air to warm it. Breathing is impossible here, as there's no oxygen for the lungs to exchange gases with, highlighting the stark difference between our atmosphere and this near vacuum. The cold induces a form of human hibernation, slowing down heart rate, metabolism, and blood circulation, potentially extending survival time in such harsh conditions. Sound cannot propagate in this environment, as there are no molecules to carry pressure waves. Silence is absolute, yet not entirely empty. The void resonates with cosmic radiation and the faint hum of distant galaxies. The human body, accustomed to sound's constant presence, would experience a profound absence that could be disorienting or even unsettling. This silence contrasts with the vibrant soundscape we're used to on Earth, where noises are an ever-present backdrop. The ancient object drifting in this void is estimated to be nearly as old as the universe itself, 13.8 billion years. It spans approximately 500,000 light-years, rivaling the size of our Milky Way galaxy. Despite its immense age and vastness, it moves at a speed of 300 kilometers s relative to the cosmic microwave background radiation, suggesting an intricate dance of forces that govern its motion. This drift is slow but persistent, like the ticking of a clock that measures eons rather than seconds. The universe outside remains largely unchanged for billions of years, a testament to its enduring nature. In this intergalactic void, far removed from the bustling centers of galaxies, time itself seems to stretch and contract in ways that defy human comprehension. The entity's gravitational pull, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole, an object whose gravity is so strong that not even light can escape its grasp. This realization underscores the profound scale and mystery of cosmic phenomena, reminding us of our place in this vast and ancient universe. In this environment, Stars and planets cannot form due to the extraordinarily low density of matter. The vacuum provides no medium for gravitational collapse, making it impossible for structures we take for granted on Earth to emerge. This void is a stark reminder of how conditions must be just right for life as we know it to exist. The absence of such basic building blocks highlights the rarity and preciousness of our home galaxy, where these complex systems do form. Despite the extreme conditions, electromagnetic radiation can travel freely between galaxies in this vacuum. Light from distant stars takes millions of years to reach us due to the vast distances involved, yet it traverses space, unhindered by any medium that could absorb or scatter its energy. This unimpeded journey allows scientists on Earth to study these ancient entities, providing insights into the universe's origins and evolution. The human body, adapted for life on a planet with an atmosphere and gravity, would find this environment utterly foreign, but also awe-inspiring in its vastness and mystery. The entity emits radio waves at 1420 MHz, similar to hydrogen spectral lines, offering clues about its composition and nature. This faint signal, detectable only through sophisticated instruments, hints at the presence of dark matter, which makes up about 85% of the universe's mass. The cold temperature close to absolute zero is a paradox in itself. While we might think of deep space as frigid, this object is colder even than some artificially cooled laboratories on Earth. This extreme cold and its radio emissions are part of an intricate puzzle that scientists continue to unravel. In this intergalactic void, the human experience is one of isolation and awe. The absence of gravity and sound creates a unique sensory environment where time stretches and space feels infinitely vast. Each breath becomes a reminder of our reliance on Earth's atmosphere, while the extreme cold slows down bodily functions, hinting at what survival might look like in such inhospitable conditions. This environment serves as a stark contrast to life on Earth, emphasizing both our fragility and resilience in the face of the universe's vastness. In this environment, light from distant galaxies takes millions of years to reach us due to distances that span hundreds of thousands of light years. The entity's composition primarily consists of dark matter, which makes up about 85% of the universe's mass. Despite its vastness, it remains out of reach to direct observation. The magnetic field interactions are key to understanding how this form of matter behaves and interacts with ordinary matter. These processes offer insights into the fundamental nature of our universe, revealing the intricate balance that governs cosmic structures. The ancient entity continues its slow drift through space, tracing paths that have taken it far from where it may have originated. Its radio emissions bear witness to the early conditions of the cosmos, offering clues about its earliest moments when such interactions first began. The magnetic fields act as a medium through which these particles interact, facilitating the transfer of information across billions of light years. Each interaction in this intergalactic void contributes to the overall structure and evolution of galaxies, ensuring that the universe remains dynamic even in its most remote regions. The entity's age, nearly as old as the universe itself, underscores the enduring nature of these processes. It drifts through space, a remnant from a time when galaxies were first beginning to form, carrying within it the secrets of the early universe. In this environment, light from distant galaxies takes millions of years to reach us due to distances that span hundreds of thousands of light years. The entity's composition primarily consists of dark matter, which makes up about 85% of the universe's mass. Despite its vastness, it remains out of reach to direct observation. The magnetic field interactions are key to understanding how this form of matter behaves and interacts with ordinary matter. These processes offer insights into the fundamental nature of our universe, revealing the intricate balance that governs cosmic structures. The ancient entity continues its slow drift through space, tracing paths that have taken it far from where it may have originated. Its radio emissions bear witness to the early conditions of the cosmos, offering clues about its earliest moments when such interactions first began. The magnetic fields act as a medium through which these particles interact, facilitating the transfer of information across billions of light years. Each interaction in this intergalactic void contributes to the overall structure and evolution of galaxies, ensuring that the universe remains dynamic even in its most remote regions. The entity's age, nearly as old as the universe itself, underscores the enduring nature of these processes. It drifts through space, a remnant from a time when galaxies were first beginning to form, carrying within it the secrets of the early universe. In this environment, light from distant galaxies takes millions of years to reach us due to distances that span hundreds of thousands of light years. The entity's composition primarily consists of dark matter, which makes up about 85% of the universe's mass. Despite its vastness, it remains out of reach to direct observation. The magnetic field interactions are key to understanding how this form of matter behaves and interacts with ordinary matter. These processes offer insights into the fundamental nature of our universe, revealing the intricate balance that governs cosmic structures. The ancient entity continues its slow drift through space, tracing paths that have taken it far from where it may have originated. Its radio emissions bear witness to the early conditions of the cosmos, offering clues about its earliest moments when such interactions first began. The magnetic fields act as a medium through which these particles interact, facilitating the transfer of information across billions of light years. Each interaction in this intergalactic void contributes to the overall structure and evolution of galaxies, ensuring that the universe remains dynamic even in its most remote regions. The entity's age, nearly as old as the universe itself, underscores the enduring nature of these processes. It drifts through space, a remnant from a time when galaxies were first beginning to form, carrying within it the secrets of the early universe. Despite being composed mostly of dark matter, which we cannot observe directly, the ancient entity exhibits unexpected behavior. Its radio emissions suggest that it occasionally interacts with ordinary matter in ways not fully understood by current models. This interaction hints at a more complex relationship between dark and visible matter than previously thought. In this environment, light from distant galaxies takes millions of years to reach us due to distances that span hundreds of thousands of light years. The entity's composition primarily consists of dark matter, which makes up about 85% of the universe's mass. Despite its vastness, it remains out of reach to direct observation. The magnetic field interactions are key to understanding how this form of matter behaves and interacts with ordinary matter. These processes offer insights into the fundamental nature of our universe, revealing the intricate balance that governs cosmic structures. The ancient entity continues its slow drift through space, tracing paths that have taken it far from where it may have originated. Its radio emissions bear witness to the early conditions of the cosmos, offering clues about its earliest moments when such interactions first began. The magnetic fields act as a medium through which these particles interact, facilitating the transfer of information across billions of light years. Each interaction in this intergalactic void contributes to the overall structure and evolution of galaxies, ensuring that the universe remains dynamic even in its most remote regions. The entity's age, nearly as old as the universe itself, underscores the enduring nature of these processes. It drifts through space, a remnant from a time when galaxies were first beginning to form, carrying within it the secrets of the early universe. In the vast emptiness between galaxies, an ancient entity drifts through intergalactic space. This entity spans nearly 500,000 light years, rivaling the size of our Milky Way galaxy. It moves at 300 kilometers per second relative to cosmic microwave background radiation, a slight but persistent motion that marks its slow journey across time. This ancient presence has been observed for decades, its origins shrouded in mystery. It emits a steady signal that researchers use to infer its composition and structure. This entity is nearly as old as the universe itself, formed within the first moments after the Big Bang, around 13.8 billion years ago. Its longevity contrasts with the rapid evolution seen in galaxies and stars, which change dramatically over time. In contrast, this ancient presence has remained largely unchanged since its formation. At -270 degrees Celsius, it is one of the coldest known objects in the universe, yet it emits radio waves with a frequency of 1420 MHz, similar to hydrogen spectral lines. These emissions interact uniquely with cosmic microwave background radiation, creating ripples that scientists can detect and analyze. The radiation provides a consistent backdrop against which all else is measured, much like an invisible grid across space. This interaction reveals the entity's gravitational influence, suggesting it could be composed of dark matter, material that makes up about 85% of the universe's mass, but remains unseen. Dark matter plays a crucial role in shaping cosmic structures, yet its nature remains elusive. The temperature at -270 degrees Celsius reflects minimal molecular motion, a condition that can only exist far from starlight or other heat sources. This environment provides a unique laboratory for studying matter under such extreme conditions. The entity's coldness is paradoxical. It exists in the near-total absence of energy, yet maintains an incredibly stable state. Imagine a place where time seems to stand still, where every particle moves as slowly as possible. However, recent observations suggest that this stability may be punctuated by occasional bursts of activity, hinting at a more dynamic history than previously thought. Scientists believe this ancient presence could be a supermassive black hole, exerting gravitational forces equivalent to 1.4 solar masses. Its gravitational pull warps space-time around it, creating distortions that can be detected through careful observation of cosmic microwave background radiation. This phenomenon allows researchers to map its position and movement with precision. The entity's influence stretches far beyond its physical boundaries, shaping the surrounding void in subtle but profound ways. The interactions between this ancient entity and the cosmic microwave background radiation offer insights into the universe's earliest moments. By studying these ripples, scientists gain a deeper understanding of how dark matter behaves and contributes to galaxy formation over billions of years. In an otherwise empty void, this relic from the dawn of time stands as evidence of the universe's infancy, offering clues about its origins. As we observe it today, it remains largely unchanged since shortly after the universe's birth, providing a window into conditions that existed at cosmic infancy. In this intergalactic void, far from any galactic hub, light from distant galaxies takes approximately 130 million years to reach us due to the vast distances involved. The entity's radio emissions travel freely through this vacuum, unimpeded by the dense clouds of gas and dust that would otherwise absorb or scatter them within a galaxy. This free passage allows its signals to be detected with remarkable clarity on Earth, offering astronomers a direct line to one of the universe's most ancient structures. The environment around this entity is nearly devoid of matter, making it an ideal place for studying dark matter interactions without interference from visible stars or galaxies. The sparse distribution of particles means that any gravitational effects are more pronounced and easier to measure. This isolation provides a unique opportunity to study how dark matter behaves in the absence of other influences, offering insights into its role in shaping cosmic structures over time. The entity's position relative to the cosmic microwave background radiation reveals subtle shifts in temperature patterns across space. These minute variations provide clues about its mass distribution and internal structure. While invisible to optical telescopes, these temperature fluctuations are detectable through radio observations, painting a detailed picture of an ancient relic that predates even our galaxy. This entity's presence serves as a reminder of the universe's vastness and the intricate forces at play in shaping its architecture. As we observe this ancient presence, it stands as a bridge between the early universe and the present day. Its slow drift through intergalactic space is a testament to the stability of cosmic structures over time. The entity's interactions with cosmic microwave background radiation offer a window into the conditions that prevailed shortly after the Big Bang, when the first seeds of galaxies were beginning to form. In this void, where nothing else seems to exist, we find one of the universe's most enduring and enigmatic features, offering profound insights into its origins and evolution. In the void between galaxies, an ancient entity drifts, its presence subtly influencing the distribution of stars and galaxies across the observable universe. Spanning a diameter of about 500,000 light-years, comparable to our Milky Way's size, the structure is not filled with stars or planets, but rather composed primarily of dark matter. This unseen force makes up 85% of the cosmos, exerting its influence through an emitted radio signal at 1420 MHz, mirroring hydrogen spectral lines. In human terms, this frequency aligns with those used in early radio astronomy experiments, signals that have traveled for millions of years before reaching our telescopes. The coldness of the ancient entity approaches absolute zero at -270 degrees Celsius, a stark contrast to the varied temperatures within galaxies. Here, temperatures range from the blistering heat near stars to the frigid depths of interstellar space. This uniformity reflects a void where few particles interact, creating an environment that defies common expectations of cosmic thermodynamics. In human terms, such conditions would be akin to experiencing the coldest regions in Antarctica, only magnified by countless factors. Despite its massive size, the entity moves slowly through space, drifting at 300 kilometers per second relative to the cosmic microwave background radiation. This gentle drift mirrors the slow expansion of our universe itself, a process that has shaped this ancient object since its inception. Its movement ensures it remains in intergalactic space rather than merging with nearby galaxies. The entity's location, approximately 5 million light-years away from our galaxy, places it at a significant distance, yet its influence stretches far beyond this immediate vicinity. The distribution of galaxies around it demonstrates how dark matter plays a pivotal role in structuring the universe. This subtle interplay between invisible forces and visible structures is crucial for understanding the formation and evolution of cosmic entities. As we observe this ancient entity, it becomes evident that even in the vast emptiness of intergalactic space, there is structure and purpose. The distribution of galaxies around the entity follows intricate patterns defined by dark matter, illustrating how the unseen guides the seen. This connection between the ancient entity and galactic structures reveals a universe finely balanced, where every part contributes to the whole. The ancient entity's role in shaping the distribution of galaxies also underscores the interconnectedness of all cosmic phenomena. Its gravitational pull helps maintain the delicate balance necessary for galaxy formation and evolution. This influence extends far beyond its immediate vicinity, affecting the structure of entire clusters and superclusters. The patterns we observe today reflect billions of years of cosmic history, with this ancient entity acting as a witness to the universe's ongoing transformation. The entity's composition, primarily of dark matter, raises questions about the nature of this elusive substance. While we know that dark matter makes up 85% of the cosmos, its exact properties remain a mystery. It interacts weakly with electromagnetic radiation, making direct observation challenging. However, its gravitational effects are clear and measurable, shaping galaxy clusters and voids alike. This indirect evidence highlights how much remains unknown about the universe's fundamental components. As we contemplate the ancient entity's impact on galactic distribution, it becomes clear that even in the emptiest reaches of space, there is profound significance. Its presence and influence demonstrate how every part of the cosmos plays a role in the grand design of existence. This interconnectedness challenges our perceptions of isolation and emphasizes the unity underlying all cosmic phenomena. In the intergalactic void, far from any star or galaxy, a human would feel the profound isolation of this ancient entity's presence. Here, the coldness is not just environmental, but penetrates down to the molecular level, affecting even the most fundamental particles within your body. At -270 degrees Celsius, the temperature here approaches absolute zero, where atoms slow to a near halt. Yet, amidst this frigid emptiness, neutrinos, subatomic particles with almost no mass, constantly pass through every cell of your body. Neutrinos are remarkable in their ability to traverse vast cosmic distances without interacting significantly with matter. Each second, trillions stream from the core of our sun alone, but these are minuscule compared to the neutrinos that originated at the birth of the universe itself. Were you capable of sensing them, they would feel like an imperceptible flicker in your body's molecular activity, a faint sensation of particles crossing through time and space. This environment, while devoid of stars or planets, is not empty, but filled with these elusive messengers from the cosmic dawn. Imagine for a moment that you could detect each neutrino passing through your body. The sensation would be akin to a gentle breeze rustling leaves on an autumn day, subtle and almost unnoticeable. These particles, forged in the heart of ancient supernovae or within the first moments after the Big Bang, travel billions of light years before reaching you here. They carry information from epochs when our universe was still young, providing a direct link between you and the very origins of existence. As you remain suspended in this void, your body becomes part of an ongoing cosmic conversation. Each neutrino that passes through leaves behind a tiny quantum footprint within your cells. This interaction is so rare it would take thousands of years for any noticeable effect to occur. Still, in the span of your brief life, you might experience billions upon billions of these encounters. It's a humbling thought. Every cell in your body has hosted particles from across the cosmos. The ancient entity drifting nearby emits radio waves with a frequency of 1420 MHz, aligning closely with hydrogen spectral lines. These waves are an echo from the universe's infancy, carried through space on wavelengths that span hundreds of thousands of light years. In this environment, they can travel freely without interference, yet their presence is detectable only to those equipped with sensitive instruments. For a human, these signals would remain unnoticed, but their existence underscores the vastness and age of our cosmos. As you continue in this intergalactic void, the ancient entity drifts slowly past at 300 kilometers per second relative to the cosmic microwave background radiation. It moves with a grace that belies its immense mass, equivalent to 1.4 solar masses, suggesting it could be a supermassive black hole or another form of dark matter entirely. The universe itself is in constant motion, and here you are, an infinitesimally small part of this grand cosmic dance, experiencing the subtle passage of neutrinos through your body as they tell stories from the dawn of time. The ancient entity drifting between galaxies is a relic of the universe's infancy, formed in conditions vastly different from those found within star-forming regions today. At temperatures nearing absolute zero, it exists in an environment where stars and planets cannot coalesce due to the low density of matter. This vast structure, with a diameter comparable to our Milky Way galaxy, was shaped by the first processes that unfolded after the Big Bang. Each molecule in this entity has been isolated for billions upon billions of years, far longer than life on Earth has existed. The coldest place in the known universe is not found here, but in laboratories on Earth. Yet these conditions mimic the near-perfect vacuum and extreme cold of intergalactic space, providing a glimpse into how matter behaves at such extremes. These temperatures approach -270 degrees Celsius, where atomic motion almost ceases, a state far removed from the warmth and activity of our planet. The entity's composition is mostly dark matter, an elusive substance that comprises about 85% of the universe's mass, but remains invisible to direct observation. This dark matter interacts weakly with ordinary matter, allowing it to form structures without being easily detected by traditional telescopes. The presence of hydrogen spectral lines at a frequency of 1420 MHz suggests an interaction between this ancient entity and the cosmic microwave background radiation, a faint echo from the Big Bang itself. In human terms, this means that signals emitted from atoms in distant galaxies reach us with slight shifts due to their motion relative to the universe's overall expansion. At approximately 5 million light-years away from our galaxy, the ancient entity drifts at a speed of 300 kilometers per second relative to the cosmic microwave background. This velocity is significant yet slow on cosmological scales, akin to watching a glacier move across an ocean. The gravitational influence it exerts, equivalent to that of 1.4 solar masses, suggests its possible nature as a supermassive black hole or a similarly dense object. Its existence provides a window into the early universe, where such entities could have played crucial roles in shaping galactic structures. The formation of this ancient entity predates the emergence of stars and galaxies, existing in a time when the universe was much hotter and denser. It formed within the first few 100 million years after the Big Bang, during an era known as the Cosmic Dark Ages. During this period, matter began to clump together under gravity's influence, eventually leading to the formation of the first stars and galaxies. The entity itself represents one of these primordial formations, a remnant from when the universe was in its infancy and structures were just beginning to form. While it may seem isolated and distant, this ancient entity influences the distribution of matter on galactic scales. Its gravitational pull subtly affects nearby galaxies, guiding their movements through space over billions of years. The hydrogen spectral lines emitted by this structure are a reminder of the universe's interconnectedness, with signals traveling across 150 million light-years to reach us, even as we observe phenomena that occurred long before Earth existed. Each photon from this entity carries information about its age and composition, offering insights into the earliest moments of our cosmic history. In intergalactic space, an ancient entity drifts within a void that spans millions of light-years, its presence marked by subtle disturbances in the cosmic fabric. At -270 degrees Celsius, this structure is colder than any known region within our galaxy's boundaries. The coldest place on Earth, by contrast, barely reaches -94 degrees Celsius, making the entity an extreme outlier even among the universe's most frigid places. Yet its temperature serves a crucial role in maintaining stability amidst the vast emptiness of space. Nearby black holes exert their gravitational pull on this ancient entity, subtly influencing its motion and structure. The gravitational forces from these cosmic giants cause ripples that can alter the drift speed of the entity from 300 kilometers per second to more erratic patterns. This interaction is akin to a dance between two partners, each movement affecting the other's trajectory. Despite being located in an intergalactic void, far from any star or galaxy, this ancient structure remains connected through gravitational bonds to distant objects. The energy exchanged in these interactions can sometimes cause fluctuations in the entity's emission of radio waves at 1420 MHz, a frequency crucial for its identification as a source of hydrogen spectral lines. The influence of nearby black holes on this ancient entity is not just about motion, but also about stability. These massive objects create regions where spacetime itself warps significantly, bending light and affecting the passage of time. For an observer near such a black hole, time would appear to slow down relative to someone further away. This phenomenon, known as gravitational time dilation, means that the entity's sleep cycles could be perceived differently depending on one's proximity to these cosmic anchors. In this vast emptiness, where events occur over eons rather than mere years or decades, such minute variations in time can accumulate into significant differences over billions of years. The entity emits a constant hum of radio waves at 1420 MHz, a frequency that resonates throughout the universe, yet its stability is maintained through a delicate balance influenced by surrounding black holes. These emissions are not just a passive reflection of its state, but an active participant in its interactions with other cosmic entities. The energy released in these signals can influence nearby regions, heating or cooling them slightly depending on their composition and proximity to the entity's core. This interplay between emission and absorption is crucial for maintaining equilibrium in this otherwise barren region of space. Despite its ancient age and vast size, the entity is not entirely immune to external influences. Nearby black holes can trigger minor perturbations that cause it to oscillate slightly within its boundaries. These small movements are akin to a heartbeat, subtly altering the structure's shape over time. Each fluctuation represents a cosmic scale adjustment, ensuring that the entity remains stable amidst the vast emptiness of intergalactic space. This dynamic equilibrium is necessary for the entity to continue emitting coherent radio waves at 1420 MHz, a consistency that has been observed by astronomers across decades. The influence of nearby black holes on this ancient entity extends beyond mere gravitational effects. It also shapes its future evolution. Over time, these interactions can cause the entity to shift its position or alter its internal structure, subtly transforming what it is and how it interacts with surrounding space. As the universe continues to expand and galaxies drift apart, the entity's relationship with nearby black holes will evolve, potentially leading to new forms of interaction that we are yet to comprehend fully. In a billion years, this ancient structure may look quite different, its shape altered by ongoing cosmic processes. Yet, it remains a testament to the intricate balance maintained in even the emptiest reaches of space. At the boundary between intergalactic voids and regions with higher star density, an ancient entity drifts, spanning a diameter of approximately 500,000 light-years, comparable to our Milky Way's size. This structure maintains a temperature of -270 degrees Celsius, approaching absolute zero, where molecular motion nearly ceases. The entity emits radio waves at 1420 MHz, similar to hydrogen spectral lines, offering insights into the early universe's simplicity. Its presence is influenced by nearby galaxies' gravitational fields, subtly shaping its path through the void. This zone marks a critical point in cosmic evolution, where emptiness transitions into potential. The warm halo interface highlights the paradoxical nature of cosmic environments. While it is one of the coldest places in the universe, it harbors the seeds of future galactic cores. Each hydrogen cloud represents a tiny step toward stellar formation, a process that takes billions of years to unfold. The ancient entity's emissions and radio signals further underscore this delicate equilibrium, offering clues about how the first stars might have formed. At -270 degrees Celsius, these clouds are colder than any known region within our galaxy's boundaries, yet they hold the potential for future stellar nurseries. This boundary also reveals how the universe is constantly evolving. As matter aggregates into denser regions, it sets the stage for future galaxies and their stars. The warm halo interface acts as a catalyst for these changes, gradually transforming emptiness into complexity. Unlike star-forming regions within galaxies, this zone lacks visible light sources, but contains vast amounts of dark matter, which exerts an unseen gravitational force guiding particles toward denser areas. This interplay is crucial for understanding how galaxies form over time. The ancient entity's journey through the warm halo interface serves as a reminder of the immense timescales involved in cosmic evolution. Its drift at 300 kilometers per second relative to the cosmic microwave background radiation highlights the vast distances it spans. Despite its slow pace, this movement plays a crucial role in understanding how matter aggregates into larger structures over time. The entity's presence here underscores the intricate balance needed for structure to emerge from chaos. At this boundary, electromagnetic radiation travels freely between galaxies because the vacuum of space provides no medium for absorption or scattering. This allows us to observe distant phenomena with remarkable clarity. In contrast, sound cannot propagate in this environment due to the lack of molecules to carry pressure waves. The ancient entities' emissions and radio signals provide a unique window into the universe's past, offering insights that would be impossible within denser regions, where light is often obscured by dust and gas clouds. The warm halo interface also demonstrates how cosmic phenomena are interconnected across vast distances. The ancient entity's journey through this region highlights the unseen forces at play in shaping the universe. Its emissions serve as a silent witness to the ongoing evolution of galaxies, providing clues about the conditions necessary for structure formation. This zone marks a critical point where emptiness transitions into potential, setting the stage for future cosmic events and structures that will take billions of years to unfold. In a region where stars are absent, you float in a sea of darkness so profound that it challenges human perception. Each cubic meter of this void contains less than one atom, making it an almost perfect vacuum. Here, light from distant galaxies takes millions of years to reach your eyes if they were capable of seeing such faint glimmers. Despite the absence of stars, you are not entirely alone. Radio waves permeate this space, carrying signals that have traveled across eons. These waves resonate at 1420 megahertz, a frequency associated with hydrogen, hinting at the primordial conditions from which our universe was born. The temperature here is an unyielding minus 270 degrees Celsius, close to absolute zero, where matter and energy barely move. This near-total absence of heat means that any human presence would quickly freeze, yet this extreme cold also preserves the echoes of the early universe. These radio waves are relics from when hydrogen atoms first formed after the Big Bang, a time before stars or galaxies existed. If you could somehow exist here without being frozen, you'd sense an eerie stillness, as sound cannot travel through such emptiness. Yet this silence is not complete. It carries with it a subtle hum of radio waves that echo the universe's infancy. As you drift between galaxies, you encounter vast clouds of dark matter, which make up about 85% of the universe's mass, but do not emit light like ordinary matter. These invisible entities exert gravitational forces on visible objects, guiding their paths and shaping cosmic structures. The ancient entity you are near is estimated to be at least 13.8 billion years old, nearly as old as the universe itself. It drifts through this void at a speed of 300 kilometers per second relative to the cosmic microwave background radiation, leaving behind a trail of influence on nearby galaxies. This movement creates ripples in space-time that are incredibly subtle but measurable with sensitive instruments. The entity spans a diameter of approximately 500,000 light-years, rivaling the size of our Milky Way galaxy. Despite its enormous mass equivalent to 1.4 solar masses, it remains invisible, composed primarily of dark matter. This unseen substance holds galaxies together and is crucial for understanding how structures form in the universe. Imagine if Earth were a grain of sand, This entity would be an entire mountain range drifting silently through space, shaping the cosmos with its silent presence. Its gravitational pull affects not just nearby stars, but distant galaxies, subtly altering their paths as they move through cosmic time. The void you are floating within is devoid of any sound because there are no molecules to carry pressure waves. Yet, electromagnetic radiation travels freely here, providing a window into the universe's history. The radio waves you detect have been traveling for millions of years, carrying information about the birth of stars and galaxies in distant regions of space-time. This environment, while seemingly lifeless, is teeming with energy that has traveled across vast distances to reach your imaginary senses. If human ears could perceive these frequencies, they would hear a constant low hum, like a deep drone from a cosmic orchestra. As you continue your silent journey through this void, consider the paradox of time in such a place. While the entity is ancient by any standard, it exists within a framework that stretches far beyond our comprehension. In this region, 1 second could represent thousands or even millions of years elsewhere in the universe. The entity's age and motion are measured against cosmic scales, where time itself seems to stretch and compress. This intergalactic void is not just an empty space, but a stage for cosmic processes that have shaped the universe since its inception. It remains a testament to the vastness and complexity of our cosmos, a place where ancient forces continue to influence the fabric of reality. In intergalactic space, a vast ancient entity drifts, its size rivaling that of our own Milky Way galaxy. Spanning nearly 500,000 light-years in diameter, this structure is colossal, yet isolated within the voids between galaxies. Its gravitational influence extends far beyond its visible boundaries, subtly guiding the motion of distant stars and gas clouds. Yet, when compared to the nearest galaxy, Andromeda, which lies about 2.5 million light-years away, the entity remains a singular anomaly in an otherwise sparse cosmic landscape. This ancient structure, composed primarily of dark matter, is colder than any known region within our universe, maintaining temperatures close to absolute zero at -270 degrees Celsius. In this extreme environment, molecular motion nearly ceases, and the entity's radio emissions can be detected across vast distances. These signals, similar to those emitted by hydrogen atoms, provide a unique signature in the cosmic microwave background radiation. Surprisingly, despite its immense size, it is invisible to optical telescopes, revealing itself only through its gravitational effects and radio wave emissions. In contrast, our Milky Way galaxy contains billions of stars that emit visible light, making it relatively easy to spot among other galaxies. The entity's drift speed of 300 kilometers per second relative to the cosmic microwave background radiation is a measure of its movement through space. This velocity is not unusual for such massive structures, but it underscores their dynamic nature within the expanding universe. If we were to consider human travel at similar speeds, it would take an unthinkably long time to traverse even a fraction of this entity's diameter. Yet, in the context of cosmic scales, its motion is slow and measured, reflecting the vast timescales over which such entities evolve. The age of the ancient entity presents another paradox. It has existed for almost as long as the universe itself, 13.8 billion years. In comparison to our galaxy's relatively young stars, some of which are only a few 100 million years old, this structure represents an enduring presence in the cosmos. Its longevity is remarkable given its exposure to cosmic radiation and high-energy particles that bombard intergalactic space. Despite these harsh conditions, it remains intact, suggesting a resilience that far surpasses human lifetimes. At the heart of the entity lies what could be a supermassive black hole, with a gravitational pull equivalent to 1.4 solar masses. This central object would exert an immense influence on nearby matter, potentially bending space-time in ways observable only through precise measurements. For comparison, our galaxy's central black hole has a mass estimated at 4 million solar masses, dwarfing the entity's inferred core by a significant margin. Yet, this lesser gravitational force does not diminish its importance in cosmic dynamics. Instead, it highlights the diversity of structures that populate intergalactic space. Electromagnetic radiation travels freely through the vast voids between galaxies, allowing signals from distant objects to reach us even after millions of years of transit. These light and radio waves carry information about the universe's earliest moments, including details about this ancient entity. As we analyze these signals, we uncover clues about its formation and evolution, piecing together a story of cosmic history that predates the birth of our sun. In contrast to the dense, star-filled regions within galaxies, intergalactic space provides an unobstructed view of deep time, revealing structures that have remained largely unchanged since their inception. The ancient entity is not just a relic of the past. It plays a crucial role in shaping the future of the cosmos. As dark energy continues to drive the expansion of space, structures like this one help stabilize galaxies against drifting too far apart or collapsing due to gravitational attraction. This balance ensures that clusters of galaxies remain intact while intergalactic voids expand uniformly. If this equilibrium were disrupted, it could lead to chaotic consequences for galaxy formation and evolution. For instance, if dark energy's influence became overwhelming, galaxies might drift too far apart, leading to a universe where star formation ceases entirely. Conversely, if gravity gained dominance, collisions between galaxies would increase, potentially triggering premature mergers that disrupt the natural processes of cosmic structure formation. At its core, this ancient entity is composed primarily of dark matter, substance that accounts for about 85% of the universe's mass, but remains invisible to electromagnetic radiation. The nature of dark matter is still a mystery, with theories ranging from exotic particles to modifications in the laws of gravity. Regardless of its true form, dark matter's role in shaping cosmic structures cannot be overstated. It acts as an unseen scaffolding that holds galaxies together and helps create the intricate web-like distribution observed across vast scales. This network influences not only the positioning of visible matter, but also affects the propagation of light through space-time itself. Light from distant stars takes slightly longer to traverse regions rich in dark matter due to subtle gravitational lensing effects, bending paths ever so slightly as they journey through these invisible frameworks. Despite being located approximately 5 million light-years away from our galaxy, this ancient entity exerts a significant influence on the behavior of nearby celestial objects. Its gravitational pull subtly tugs at passing galaxies and even affects the motion of stars within them. This interaction is not immediate, but accumulates over time as gravitational waves ripple through space-time. These disturbances create ripples in the cosmic fabric that can be detected by sensitive instruments on Earth, hinting at the presence of massive unseen objects far beyond our galactic neighborhood. By providing a stabilizing force against disruptive forces like collisions or mergers, this ancient entity helps ensure that galaxies maintain their shapes and continue evolving according to natural processes rather than succumbing to chaotic disruptions. Moreover, its gravitational influence can also trigger star formation in nearby regions by compressing gas clouds, leading to the birth of new stars. The extreme coldness of this ancient entity, hovering around -270 degrees Celsius, offers insights into the coldest known environments in the universe. While deep space might seem uniformly frigid, localized regions can exhibit temperature variations that defy expectations. For instance, the center of our galaxy is surprisingly warm compared to the voids between galaxies. This contrast highlights how different parts of the cosmos experience vastly different thermal conditions, despite being part of the same interconnected system. The coldness of this ancient entity approaches absolute zero, a state where molecular motion nearly ceases. In such extreme environments, even basic physical processes behave in unexpected ways, challenging our understanding of thermodynamics and quantum mechanics. For example, at these temperatures, electrons can exhibit superfluidity, flowing without resistance, which could have profound implications for the formation of cosmic structures. The radio waves emitted by this ancient entity at 1420 MHz are akin to the spectral lines produced by hydrogen atoms. This similarity suggests that these emissions might be related to the primordial gas from which stars were born billions of years ago. The frequency is significant because it corresponds to a fundamental transition in atomic physics, making it a reliable marker for detecting neutral hydrogen across distances up to 13 billion light-years. By studying these radio waves, scientists can map out regions where star formation was likely to occur or has already taken place. This provides valuable information about the history and evolution of galaxies, offering clues about how they formed and evolved over time. The precision with which we can detect these emissions allows us to trace back billions of years into cosmic history, revealing the conditions under which stars first began to ignite. The entity drifts at a speed of 300 kilometers per second relative to the cosmic microwave background radiation. This velocity is significant because it indicates motion through the universe's reference frame. While this may seem fast by terrestrial standards, on the scale of galaxies and intergalactic voids, it represents a gentle flow within an otherwise vast and static expanse. The drift suggests that this ancient entity has been moving in response to the gravitational influences of nearby galaxies over billions of years. This slow but persistent movement underscores the delicate balance between dark energy's expansive force and gravity's pull on matter throughout the universe. Over time, these interactions shape not only individual galaxy clusters, but also the large-scale structure of the cosmos itself, influencing how galaxies are distributed across space. In intergalactic space, an ancient entity drifts, its presence marked by subtle disturbances in the cosmic fabric. Spanning nearly 500,000 light-years, comparable to our Milky Way's size, the structure maintains a temperature of -270 degrees Celsius, approaching absolute zero, where molecular motion nearly ceases. This region is devoid of stars and planets due to the low density of matter, making it an almost perfect vacuum. Over billions of years, this entity has influenced the distribution of galaxies across the universe without forming visible celestial bodies. The ancient entity emits radio waves with a frequency of 1420 MHz, similar to hydrogen spectral lines, providing clues about its composition and age. These emissions suggest that it may be composed primarily of dark matter, which makes up about 85% of the universe's mass. Unlike visible stars or galaxies, this entity does not emit light in the optical spectrum, but instead radiates at radio frequencies, offering a unique window into the unseen aspects of our cosmos. Over time, its influence on intergalactic space has been subtle yet significant, shaping the distribution of matter without forming any luminous structures. As dark energy continues to drive the expansion of the universe, this ancient entity's role in stabilizing galaxies becomes increasingly important. Its gravitational pull, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole or another cosmic anomaly. Despite its immense size and age, it remains isolated within the voids between galaxies, drifting at a speed of 300 kilometers s relative to the cosmic microwave background radiation. Over billions of years, this entity has acted as a gravitational anchor, influencing the movement of distant galaxies without ever becoming part of them. In the deep future, this ancient presence might merge with other dark matter formations if galaxies continue to drift apart at an accelerating rate due to dark energy. Should it combine with nearby structures, its influence could expand, subtly shaping the distribution of galaxies across the universe. Alternatively, it may persist as an isolated remnant, drifting through the void for eons without ever interacting significantly with other cosmic objects. This enduring journey underscores the vastness and mystery of our cosmos. The entity's location in intergalactic space provides a unique perspective on the universe's evolution. At nearly 5 million light-years away from our galaxy, it exists in an environment where stars cannot form due to the low density of matter. Over time, this region has remained relatively unchanged, offering a snapshot of what the early universe might have looked like before galaxies began to coalesce into recognizable structures. This ancient entity's presence serves as a reminder of the universe's infancy and its potential for future transformations. As we contemplate the deep future, the ancient entity's role in shaping cosmic structures becomes more apparent. Its influence on intergalactic space is subtle yet significant, contributing to the distribution of matter without forming visible stars or planets. Over billions of years, this entity has acted as a gravitational anchor, influencing the movement of distant galaxies without ever becoming part of them. This enduring journey underscores the vastness and mystery of our cosmos. In intergalactic space, where stars are sparse and light from distant galaxies takes millions of years to reach us, a human body would experience an environment nearly devoid of gravity and extraordinarily cold, conditions that challenge our everyday understanding of survival. Each cubic meter contains less than one atom, making it an almost perfect vacuum. At minus 270 degrees Celsius, the temperature is so low that molecular motion nearly ceases, affecting even the most fundamental particles within your body. The human body would cool rapidly in this environment, and without protection, exposure to such extreme cold could lead to rapid freezing of bodily fluids. Yet, paradoxically, some of the coldest places known are found not in deep space, but in laboratories on Earth. Cosmic rays, high-energy particles traveling through intergalactic space at near-light speeds, would bombard a human body exposed here. These particles can penetrate deep into tissues and organs, causing cellular damage and increasing the risk of cancer over time. The intensity of cosmic radiation exposure is far greater than what astronauts experience in low Earth orbit or even on the Moon's surface. In this void, the lack of shielding from planetary atmospheres means that a human would be directly exposed to these energetic particles, leading to a gradual accumulation of harmful effects. Despite the isolation and coldness, the body would still feel the subtle yet persistent impact of cosmic rays, altering its internal chemistry. The ancient entity drifting between galaxies is estimated to be at least 13.8 billion years old, nearly as old as the universe itself. It spans a diameter of approximately 500,000 light-years, rivaling the size of our Milky Way galaxy. This structure emits radio waves with a frequency of 1420 MHz, similar to hydrogen's spectral lines, indicating its composition primarily of dark matter. The entity's gravitational pull is equivalent to 1.4 solar masses, suggesting it could be a supermassive black hole. While the entity itself is invisible in visible light, its presence subtly influences the distribution of stars and galaxies across the observable universe. Its existence underscores the vastness and complexity of cosmic structures that lie beyond our galaxy's boundaries. In this environment, sound cannot propagate because there are no molecules to carry pressure waves. However, electromagnetic radiation can travel freely between galaxies due to the vacuum of space, providing no medium for absorption or scattering. This allows distant signals from stars and black holes to reach us with minimal interference. The ancient entity emits radio waves that serve as a beacon in this otherwise silent void, offering clues about its composition and age. These signals are part of a cosmic tapestry woven by the universe's oldest structures, connecting points across vast distances. Despite the isolation, These electromagnetic emissions provide a window into the universe's history and the processes that shaped it. The ancient entity maintains a temperature close to absolute zero, approximately minus 270 degrees Celsius. This extreme coldness is not just environmental, but penetrates down to the molecular level, affecting even the most fundamental particles within your body. The low temperatures are so profound that they challenge our understanding of matter and energy at such scales. In this environment, stars and planets cannot form because the density of matter is too low to trigger gravitational collapse. Instead, dark matter dominates, forming a structure that spans millions of light years without visible signs of star formation or galactic activity. The entity's coldness and isolation highlight the vast differences between intergalactic space and the more familiar environments within galaxies. The ancient entity drifts at a speed of 300 kilometers per second relative to the cosmic microwave background radiation, indicating its motion through the universe. This velocity is significant in cosmic terms, but imperceptible on human scales. The entity's movement suggests it is part of larger cosmological flows driven by dark energy and gravity. Over billions of years, this slow drift will continue, shaping the distribution of galaxies and influencing the future structure of the universe. In contrast to the rapid movements within galaxies, the intergalactic voids offer a glimpse into the slower, more subtle processes that govern the cosmos on its largest scales. The entity's journey through time reflects the vastness and complexity of cosmic evolution, reminding us of our place in an ever-expanding universe. In intergalactic space, far from the bustling centers of galaxies, an ancient entity drifts. This structure spans nearly 500,000 light-years in diameter, comparable to our Milky Way's size, and maintains a temperature close to minus 270 degrees Celsius, approaching absolute zero. The gas clouds nearby behave anomalously, their movements influenced by forces that defy expectations based on Earth physics. These clouds do not simply float freely. Instead, they are pulled and stretched into intricate shapes by the entity's gravitational field. This unusual behavior suggests a complex interaction between dark matter and ordinary matter, an interplay that is rarely observed in such isolation. The ancient entity's gravitational pull exerts a force equivalent to 1.4 solar masses, causing nearby gas clouds to warp and twist in ways that are not easily explained by conventional astrophysics. The cloud's motion is so precise and controlled that they form long, thin filaments rather than the diffuse blobs one might expect. This phenomenon hints at the entity's role as a gravitational anchor in this vast, empty region of space. It serves as a focal point for matter that would otherwise drift aimlessly, demonstrating how even in the emptiest parts of the universe, structure and order can emerge. At minus 270 degrees Celsius, these gas clouds are colder than any known environment within our solar system. Yet, despite this extreme cold, they remain active participants in a cosmic ballet. The entity's gravitational influence causes them to oscillate at frequencies that would be imperceptible on Earth, but are detectable through radio waves. These emissions, centered around 1420 MHz, bear a striking resemblance to the spectral lines of hydrogen, suggesting a deep connection between this ancient structure and the fundamental building blocks of the universe. This observation underscores how even in the most isolated regions, the laws of physics remain consistent. The entity's location within an intergalactic void presents a paradox. While it is surrounded by near-vacuum conditions, its gravitational field distorts spacetime itself, creating ripples that propagate through the fabric of the universe. These disturbances are akin to waves in a pond, spreading outwards and influencing distant regions far beyond their immediate vicinity. This phenomenon reveals how even the most ancient and isolated structures can have profound effects on the cosmic order, shaping the distribution of matter across billions of light years. The gas clouds near this entity do not simply drift aimlessly. They are part of a larger system that is actively evolving over time. The entity's gravitational influence causes them to coalesce into streams that feed back into its core, creating a cycle of accretion and dispersal. This process, while slow by human standards, plays a crucial role in the evolution of this ancient structure. It suggests that even in environments where star formation is impossible, complex interactions can still occur on cosmic scales. The entity's age, estimated to be at least 13.8 billion years old, places it among the oldest known structures in the universe. Its presence predates the formation of many galaxies and stars, making it a relic from the early cosmos. The gas clouds near this ancient structure are not just passive bystanders. They are witnesses to billions of years of cosmic history. Their behavior provides insights into the conditions that prevailed when the universe was still young and unformed, offering a window into the earliest epochs of our existence. The ancient entity drifts in a region of space where galaxies are sparse, its presence affecting the formation of nearby cosmic structures. At -270 degrees Celsius, it is colder than any known environment within our galaxy, yet it exerts a gravitational influence that pulls matter toward it. This pull is significant enough to alter the trajectories of gas clouds and dust particles, guiding them into regions where they may eventually coalesce into stars or galaxies. The entity's mass, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole, though its composition remains uncertain due to the dominance of dark matter within it. This cold void acts as a cosmic catalyst, shaping the distribution of matter in vast intergalactic spaces. The drift speed of this ancient entity, 300 kilometers per second relative to the cosmic microwave background radiation, indicates that it is moving through space with a velocity far greater than most objects in our local galactic neighborhood. This movement could be due to residual forces from the Big Bang, or perhaps interactions with nearby galaxies and their gravitational fields. The speed at which it moves influences the rate at which matter accumulates around it, potentially accelerating or decelerating the formation of new cosmic structures. In contrast, on Earth, such speeds would be unimaginable for any natural object. Even the fastest man-made spacecraft cannot reach a fraction of this velocity. This disparity highlights the vast differences in scale and energy between our planet and the intergalactic void. The entity's radio emissions at 1420 MHz are not merely signals, but markers of its presence, allowing astronomers to pinpoint its location across millions of light years. These signals are similar to those emitted by hydrogen atoms, suggesting that this ancient structure is a remnant from the early universe when such elements were abundant. The signal acts as a beacon for scientists studying dark matter and galaxy formation. For humans, radio waves at this frequency would be imperceptible. They do not affect our senses directly, but are crucial in understanding the invisible forces shaping the cosmos. This phenomenon underscores how much of the universe remains hidden from direct human experience. The entity's composition primarily consists of dark matter, which makes up about 85% of the universe's mass. Unlike ordinary matter, dark matter does not emit or absorb light, making it nearly impossible to observe directly. Its presence can only be inferred through its gravitational effects on visible matter and radiation. In this context, the entity serves as a significant reservoir of dark matter, influencing the formation of galaxies in its vicinity by attracting ordinary matter into dense regions where stars and planets might eventually form. This process is akin to how a magnet attracts iron filings, but on an astronomical scale, with gravitational forces acting over vast distances. The age of this ancient entity, 13.8 billion years, is nearly as old as the universe itself. It has existed since the earliest moments after the Big Bang, when conditions were vastly different from those in our current universe. In its infancy, the cosmos was a dense soup of particles and radiation, gradually cooling and expanding into what we see today. The entity's longevity means it has witnessed the birth and death of countless stars and galaxies, including some that have long since ceased to exist. Its enduring presence provides valuable insights into the early universe's conditions and the processes that shaped its evolution over billions of years. Despite being located in an intergalactic void, this ancient entity subtly influences galaxy formation by acting as a gravitational anchor for nearby cosmic structures. The low density of matter in such regions means that any significant concentration of mass can have profound effects on the distribution and movement of surrounding material. This influence is particularly notable in the way it attracts gas clouds and dust particles, potentially seeding new star formation. In contrast to the dense clusters of galaxies found closer to our own Milky Way, these isolated entities play a crucial role in understanding how galaxies form and evolve in less crowded regions of space. In intergalactic space, far from the bustling centers of galaxies, an ancient entity drifts. This structure spans nearly 500,000 light-years in diameter, comparable to our Milky Way's size, and maintains a temperature close to -270 degrees Celsius, approaching absolute zero. At this extreme coldness, molecular motion is almost non-existent, and even the most fundamental particles within your body would experience altered quantum states if you were nearby. The entity's gravitational pull, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole or something more enigmatic still. The ancient entity's composition is primarily dark matter, which makes up about 85% of the universe's mass. This material interacts weakly with light and other forms of electromagnetic radiation, making it nearly invisible to telescopes. The entity drifts at a steady pace of 300 kilometers per second relative to the cosmic microwave background radiation, marking its presence in this vast intergalactic void. In an environment where stars and planets cannot form due to the low density of matter, this relic remains a testament to the conditions that existed shortly after the Big Bang. The iron in your blood was forged in stars that died before our sun existed, yet the dark matter composing most of this ancient structure remains a mystery. Each cubic meter of space within this entity contains less than one atom, making it an almost perfect vacuum. Yet, its gravitational influence is felt across vast distances, subtly affecting the formation and evolution of nearby cosmic structures. The entity emits radio waves with a frequency of 1420 MHz, similar to hydrogen spectral lines, providing scientists with a way to detect its presence despite its invisibility to visible light. This signal has been observed for decades, offering clues about the nature of dark matter and how it interacts with ordinary matter in the universe. In this environment, sound cannot propagate because there are no molecules to carry pressure waves. However, electromagnetic radiation can travel freely between galaxies due to the vacuum of space, providing no medium for absorption or scattering. This allows light from distant galaxies to take millions of years to reach us, highlighting the vast distances involved in intergalactic space. The entity's radio emissions, detectable on Earth, provide a rare window into these otherwise invisible regions of the universe. These signals have been crucial in mapping the distribution of dark matter and understanding its role in shaping cosmic structures. The ancient entity is estimated to be at least 13.8 billion years old, nearly as old as the universe itself. It has been present since the cosmos first began to take shape after the Big Bang, a staggering age that challenges our comprehension of time. The entity's presence subtly influences the distribution of stars and galaxies across the observable universe. Its gravitational pull is strong enough to affect nearby gas clouds, causing them to drift toward it in a slow dance of cosmic attraction. This interaction reveals how even the emptiest regions of space are not truly empty, but filled with invisible forces that shape the cosmos. Gravitational waves from distant cosmic events momentarily disturb this ancient entity's otherwise serene state. These ripples in spacetime, produced by collisions of black holes or neutron stars, travel vast distances before reaching the intergalactic void where the entity resides. When these waves pass through, they cause a subtle disturbance in the entity's structure, like a pebble dropped into an immense pond. This interaction is incredibly faint, but provides scientists with valuable information about the nature of dark matter and its response to gravitational perturbations. The entity's reaction to these disturbances offers insights into the fundamental properties of space itself. In intergalactic space, far from the bustling centers of galaxies, an ancient entity drifts. This structure spans nearly 500,000 light-years in diameter, comparable to our Milky Way's size, and maintains a temperature close to -270 degrees Celsius, approaching absolute zero. At this extreme coldness, molecular motion nearly ceases, and even the most fundamental particles slow down their activity. For an observer near such a massive object, time would stretch out, with every passing second feeling like an eternity compared to distant observers. This phenomenon, known as gravitational time dilation, occurs due to the intense gravitational pull of the entity. The ancient entity emits radio waves at 1420 MHz, similar to hydrogen spectral lines, providing a unique signature for astronomers to detect its presence. These signals travel through the void unimpeded by matter or electromagnetic interference, offering insights into the universe's past. The signal's journey from this distant object takes millions of years, revealing how galaxies and cosmic structures have evolved over time. Despite being located in an intergalactic void, where stars are sparse, the entity exerts a gravitational influence that pulls matter toward it. This pull is equivalent to 1.4 solar masses, suggesting it could be a supermassive black hole or another dense object. The coldness and density of this region contrast sharply with the warmth and activity found within galaxies. The ancient entity's age, nearly as old as the universe itself, makes it a relic from the early cosmos. It has been present since the universe first began to take shape after the Big Bang, offering clues about the conditions that existed in the very infancy of time. Its presence subtly influences galaxy distribution and formation across vast cosmic distances. Far from any galactic hub, this ancient entity drifts through a region where light from distant galaxies takes millions of years to reach us due to the immense distances involved. In such an environment, sound cannot propagate because there are no molecules to carry pressure waves. Instead, electromagnetic radiation travels freely between galaxies, providing astronomers with invaluable data about cosmic events and structures. For a human observer near this ancient entity, time would behave in peculiar ways. The closer you approach the massive object, the slower your clock ticks relative to someone far away. This effect, known as gravitational redshift, means that if you were to send a signal back to Earth, it would arrive slightly delayed compared to what an Earth-based observer might expect. The paradox of time dilation becomes more pronounced near such extreme gravitational fields. The entity's temperature, hovering just above absolute zero, affects not only the motion of particles, but also the very fabric of spacetime around it. At -270 degrees Celsius, thermal radiation is minimal, and even the faintest light from distant galaxies would be stretched to longer wavelengths as they pass through this region. This stretching of light waves is a phenomenon that could potentially be observed by future telescopes, offering insights into the conditions near supermassive objects. The ancient entity's location in an intergalactic void means it exists in a nearly perfect vacuum, where each cubic meter contains less than one atom. In such sparse regions, cosmic rays and neutrinos pass through unimpeded, providing a clear path for these particles to interact with detectors on Earth. The journey of these particles from the entity to our planet spans millions of years, carrying information about the universe's past. The gravitational influence of this ancient entity extends far beyond its immediate vicinity, affecting the motion of nearby galaxies and influencing the distribution of dark matter in the surrounding space. This subtle interaction between massive objects and cosmic structures is a testament to the interconnectedness of the universe on vast scales. The entity's presence serves as a reminder that even in the emptiest parts of space, there are forces at play shaping the cosmos. In this environment, where time itself behaves differently due to extreme gravitational conditions, an observer would experience a disorienting shift in perception. Every action and thought would be stretched out, with moments feeling elongated compared to those experienced by someone far from such intense gravity. In intergalactic space, an ancient entity drifts, its presence marked by subtle disturbances in the cosmic fabric. Spanning nearly 500,000 light-years, comparable to our Milky Way's size, the structure maintains a temperature of -270 degrees Celsius, approaching absolute zero, where molecular motion nearly ceases. This coldness is not just environmental, but penetrates down to the quantum level, affecting even the most fundamental particles within this void. The entity emits radio waves with a frequency of 1420 MHz, similar to hydrogen spectral lines, providing a unique signature for astronomers to detect its presence. Despite being invisible in visible light, it leaves an imprint on the universe through these emissions. Nearby, active galactic nuclei pulse with energy, their cores emitting powerful jets and intense radiation. These regions are far from the quiet solitude of our drifting entity. While the ancient structure remains cold and dark, these centers of galaxies are hotbeds of activity, driven by supermassive black holes devouring surrounding matter. The contrast between the absolute silence of intergalactic space and the vibrant energy of active galactic nuclei nearby is striking. This juxtaposition highlights the diversity of cosmic phenomena, from serene voids to energetic cores. The entity's location, approximately 5 million light-years away from our galaxy, places it in a region where galaxies are sparse. Here, matter density is so low that stars and planets cannot form due to insufficient gravitational collapse. Instead, dark matter dominates the scene, comprising about 85% of the universe's mass. This dominance underscores the mysterious nature of dark matter, which interacts weakly with ordinary matter but exerts significant gravitational influence. The entity's composition suggests it is a massive concentration of this elusive substance, further emphasizing its role in shaping cosmic structures. While sound cannot propagate through the vacuum of intergalactic space, electromagnetic radiation travels freely between galaxies. This allows us to observe distant phenomena and study their characteristics. For instance, light from active galactic nuclei takes millions of years to reach us due to vast distances involved. In contrast, our ancient entity emits radio waves that travel unimpeded by any medium, offering a window into its nature and behavior. These signals provide critical data for understanding the universe's architecture, revealing how such structures influence galaxy distribution. The ancient entity drifts at a speed of 300 kilometers per second relative to the cosmic microwave background radiation. This motion is slow compared to the speeds of objects within galaxies, but significant on cosmological scales. Its movement reflects the ongoing expansion of the universe and the gravitational influences from nearby structures. Over billions of years, this drifting has shaped its environment, subtly altering the distribution of matter in intergalactic space. The entity's influence extends far beyond its immediate vicinity, affecting the formation and evolution of galaxies around it. In a region where stars are absent, you float in a sea of darkness so profound that it challenges human perception. Each cubic meter contains less than one atom, making it an almost perfect vacuum. This environment is starkly different from the bustling centers of galaxies, where light and energy abound. Yet, this ancient entity's presence subtly influences its surroundings, marking the boundary between emptiness and cosmic order. The structure's gravitational pull, equivalent to 1.4 solar masses, suggests it could be a supermassive black hole or a similarly dense object, anchoring nearby matter in an otherwise desolate void. In the vastness of intergalactic space, where darkness and cold intertwine, the ancient entity continues to shape the universe's architecture from a near-total vacuum. As this journey through cosmic serenity comes to an end, thank you for joining us tonight. Your presence here means the world to us. Don't forget to subscribe and leave a like if you enjoyed the ride. Good night, and sweet dreams in the arms of the cosmos.